Okay, welcome everyone. So today what we are doing is we are trying to estimate a Johanson approach VECM model on Eviews. Before starting, I will introduce my data. So the variables that I am going to discuss is there is a variable here in this list is let me see. Okay, this one is yes. So this one is let me open all of them. So T D and this one and let me open quality. Okay. Okay, so these are few variables, and if I want to see all of them together, so I will open it as a group. So here the variables are total tax revenue. Okay, so this is the data that I selected from Economic Survey of Pakistan, and this is total tax reforms. This is estimated using discourse analysis in economic survey. This is data of inequality. It has too many missing values, so I might probably not use it. And this is GFCF, it is investment gross fixed capital formation. So all the fixed capital that has been produced in a country, and we usually use it as a proxy for in physical investment in the capital investment in the country. And this is exchange rate data. Okay, so let me close it. First of all, before we start Johanson approach, we need to make sure that our variables are non-stationary. So I will open tax reform variable and I will go and make its graph. So fastest way to make graph is open the variable and go in graph. And when you press graph, it will ask what type of graph you want. So when I press OK, it will show me a graph of the data. So I observe that this data does not have, this data is not starting from zero. It has some physical value. If I let's see, if I annotate, if I draw a most representative straight line on it, it will be like this. Since the most representative line is not starting from zero, so and the starting point of line is also not zero, so this confirms that the data is not starting from origin. So since it is not starting from origin, we should not use the no constant method of unit 2 test. And since this most representative line does not have any angle, it looks like it's an horizontal line. Other than there's why it looks like horizontal, because the blue line is actually revolving around it. So it was at the start it was below, and then it came above, and then went below and above. So it is not showing any persistent increase. So it shows that the line does not have any trend. So this variable, for this variable, what I will do is that I will use a unit 2 test with constant only. So how to do a unit 2 test? We'll go in view and unit 2 test. And most common is augmented decoupler. And I usually use the automatic lag selection criteria so that it selects its lag automatically. If you use this user specified, then you have to give a reason why you select one. But if you use automatic, you can write in your write-up that I'm using SIC criteria. You can use any other, but by default it is SIC. First of all, I will check it at level and intercept, because the graph is showing that it should be intercept, and I will check it at level. So when I open it up, so in good software, you don't have to remember how to interpret. So all you will need you to do is you see the null hypothesis. So here null hypothesis is that the TRE variable has a unit root, means it is non-stationary. So here the probability value is greater than 0.05. This confirms that the variable is non-stationary at level, because we checked it at level. Okay, so let me write few things here, because so since variable is non-stationary at level, it confirms that it is not I0. I0 means stationary at level. So but it may be I1 or I2. So the variable can be I2. So but with my experience, I have not seen many variables which are I2, but it can be. theoretically it can be. So we need to rule out that the variable is not I2. So for that, what we'll do is we go back and we select unit 2 test again. We'll check it at first difference. At first difference, when I do it, it should be significant. Okay, so the unit root test is significant at first difference. It confirms that the variable is I1. So similarly, all of your variables should be I1 before you use the unit root, before you use the Johanson approach. Okay, so this way you can check all the variables and confirm that they are I1 in nature. Okay, so this way this test is done this way. But there is another problem. This unit 2 test process is not that reliable. So the sometimes some variables are on the borderline. So the best way is you should use at least 2 types of unit 2 tests, so that you can have a consensus that at least 2 of them are saying the same thing. If 2 of them have a conflict, then use 3 and select the which test is where to 2 are falling. So select the majority. So for that you can go there and select the Philip Perrin. You can also select KPSS and GParent. They all are very good. But on the other side, you can also use the breakpoint unit to test. So in breakpoint unit to test, what you can do is it will check for the stationarity, allowing for any structural break in the data. Sometimes the data is not non-stationary, but because there was a structural break, the data looks like non-stationary. So we need to check it for. So this is a non-stationary unit to test. So it says that data is a unit root and it is insignificant. So it confirms that variable is non-stationary. So this way you can confirm. So this test can be done in Eviews 9. So it is allowing a intercept break to see if we allow for a break, does the variable become stationary or not. So it is still non-stationary. It means the data was not non-stationary because of the break. It was because of its actual nature. So this confirms the nature of the data. So this way we can do the unit 2 test. Second is for doing your for your cointegration test. First of all, you need to check the lag order criterion. So we'll select the variables, the total tax revenue, tax reform. I will select the trade openness, and also I will select some other variable like GFCF, where it was GFCF, and let me see if there is any other important variable that can be used. So I will select political stability. Oh, so control, if you press control, you can select all of them. Control dependent variable first, and you'll select the polity, which is political stability, trade openness. You select investment. So these are your 1, 2, 3, 4, 5 variables. So I will open it as a group. Here the variables are there. So it's political stability or democratic quality, and these are other variables. So I will go with the. So you will open it as a group when you need to do the cointegration test. We need to open it as a var. So we first of all will estimate var. So unrestricted var, because we don't know what kind of restriction we need to apply. So we'll run the unrestricted var. So why it is called var? Because each dependent variable has variables in lag. All the variables are in past. So tax reform past, tax reform second past, tax revenue first past, second past, tax reform first past, second past, polity first past, second past, trade openness first. So it's a, so there are 4 variables. So there are 4 AR equations, and since they are estimated together, so that's why it's var. So let's see. So this model is var as V is for vector where 4 equations are treated simultaneously, and AR is for autoregressive, where all the IVs are in lag form. So this way it's called VAR, vector autoregressive. Okay, so let's clear it up. So now VAR model will be our baseline model if there is no cointegration. Okay, so and there are other conditions, but we'll see later on. So this is our now what we'll do is we'll go there and we'll check for lag order. So it's in lag structure and lag length criteria. Okay, what it is doing is it will find us how many lags should be there for each variable so that the model does not have any missing variable bias. So it means that if you add more variables, the model becomes complicated. But if you reduce the variables, the model may lose power to explain. So lag length criteria will find us the optimal size of lag where the power is good enough and it is not complicated. So we'll check for up till lags. So it will check up till 4, from 0 to 4. And it is used 5 methods: log likelihood, likelihood ratio, and final prediction error, Kai criteria, Schwartz criteria, and Hanan and Quinn criteria. So it has placed stars where the value is minimum. Okay, for log likelihood it's the highest value, and for others the minimum one. So star is there, star is there, star is there. So out of 5 stars, 4 are at lag 1. So it means we will select lag order 1. So it is optimal lag. So this way you can do the lag length criteria. Okay, so if you want to study more, you should study that what is the so why we use optimal lag, because these tests use the penalty factor that if you add more lags, the model becomes complicated. But we don't need a complicated model. So it compares the power of the existing lags and the complicatedness that it will attract if you add more lags. So if the power is higher than the complicatedness, so it will stay stop. Otherwise, it will say that you should add more lags. So currently, it is saying that 1 lag is sufficient because our data is not long enough with 34 observation. If you have data long enough, or if your data is quarterly or monthly, it may say you more lags. Okay, so this is the lag length criteria. So let's close it up. Let's and now we go for view and we go for cointegration test. In the cointegration test, now there are 5 types of test and 6th one is the summary. Okay, so what I do is I will first of all update the lags, lag 1. Okay, and sometimes you have few variables which you know that its lag is not affecting the dependent variable. You can put that variable here, which is called exogenous variable. So exogenous variable means the variable which is granted that it will not be a dependent variable in the model. Like other variables, VAR model checks all the variables to be a possible dependent variable. So if you give them 4 variables, it will try to estimate 4 equilibriums. But if you know any a specific variable which cannot be a dependent variable, for example, one of my variable is population. So I know that my GDP does not affect population. So population cannot be a dependent variable. Or my dependent variable may be land size, area. So I know that area is not affected by other variables. So I, rather than selecting it earlier, I will select that variable here. I will write the variable exogenous variables here. So let me write it here. So exogenous variables are those variables which are confirmed not to be explained by the model. Means any other variable in the model. So this way you confirm that there is. I give you 2 examples, so you can put it here. Sometimes people create a structural break dummy and they put it here because we already know structural break is not being caused by the variables which are in the model. So what I will do, first of all, for economics and social sciences, model 3 and 4 are more optimal. But if you want to use 1, 2, and 5, you need to give justification. But how to find it? So there are few ways. I will let show you. I can show you here first. So let's close it up. Let's go back and see how to find that which one is correct. So let me close it up. Okay, let's get some rough idea how to see which one should be used. So I will close these estimates and open it up as an equation and run simple OLS. Okay, when I estimate this OLS, first of all, the model should be significant, otherwise you cannot go forward. Then you plot the residual graph. So let's show it here. So this is the residual plot. So the blue line is the residual of the model. So you see that the residuals do not have so residuals are actually not they look like they are around 0, but they are a little bit higher because at few stages it was outside the critical boundary, like here 1992 and like here. So it means that since they went out of the boundary sometimes, so it means that the average of the residual is not 0. So but they do not have any trend, so it means it should be constant only. If the residuals were inside this critical boundary and there is no pattern, we should have said that it is no constant. So this way you can get an idea that there should not be any trend. Secondly, the other way you can check is that in your unit 2 test, none of the variable had any trend, so the Cointegration should not have any trend. So this way you can confirm. Now we'll go towards var again. So we'll select var and we'll run the var as it is. Now we'll go for the Cointegration test, and since we know that we should use lag order 1, and now we use no intercept. We will not use intercept in CE and no intercept in var. So CE is the long run and var is short run, and intercept in CE and in var. So it means we will use intercept in long run and short run both. Okay. So second thing is, if you're not sure, adding an intercept will not hurt anything. But if you ignore it and in reality intercept was there, then it will be a problem. So if you include an intercept and it was not there, it will become insignificant. So there is no problem. So it is mentioned in a Gujarati econometrics book that adding an intercept in the model where intercept was not needed is not as harmful as not adding intercept where intercept was needed. So it means because intercept will become insignificant anyways if it was not needed. But if it was needed and you exclude it, it will create problems in your estimates. Okay, so let's move. So I will use intercept in both. So even if it is insignificant, not needed in short run, it will become insignificant. Okay, but before going here, what I usually do is I select 6 and go for summary. So let's do the summary. So what does it do is it gives me how many equilibrium are there for each type. So type 1, type 2, type 3, type 4, type 5. So it is saying that if I use the second model, it is giving me 1, 1. And if I use none, it will give me 2, 2. If I do, so what is this? these numbers are actually a summary of 5 types of integration tests. So if you want to prove that there is only one long run relation and it is stable, then all of these tests should report 1, or at least you should select the test which is where the trace and max eigen are reporting same 1. Okay, but the beauty of this model is you can prove more than one equilibrium if your theory is allowing it. So it means I should use the second model for this tutorial where it is showing 1 1, because it will give me stable and significant results. But other than that, I was trying to go for third. So I will go back and I will use the second model and go to 1 1 and okay. So here my first test is saying me that there is one cointegration equation. How it is confirmed? Because the first line is significant, which means the cointegration is more than 0, and the second line is insignificant, which means that the cointegration equation is not more than 1. So let me write it here. So first line is showing significance and second line is showing insignificance, which significance, which means the there are more than 0 cointegration relationships in selected variables. And the second line is insignificant, means there is no more than one cointegration relationships in selected variables. So it means it is more than 0 and it is not more than 1. So what is the answer? It should be 1. So it is written here. Similarly, the second test is also saying same thing. So it is confirmed that there is one long run relation, and now we'll go for and now one long run relation. Now we need to check what is that. So the best way is to go here and see this table. This normalized integration coefficients. Since it is saying 1, so we'll stay at the 1. If it was saying 2, we'll check 2. If it was saying 3, then we'll select the appropriate one. Okay, but since it is selecting 1, so we'll stop it here, and otherwise all the tables are there. So now let me iterate it here. What does it mean? So since it is written in the form of y minus y hat format, so we need to confirm equal to error term format, and error term is actually so it's this format. So we need to confirm it, convert it into y is equal to y hat plus error format. It means what we will do is we'll have to switch the signs of all the independent variables. So we'll write the equation here. So y, which is TTRE, is equal to intercept 14.92. So sign is switched because it has went to other side. So plus 1.002 TREF plus 0.017 POL plus minus 0.309 TREDE plus 0.116 G EF CF. So this is our estimated equation. Okay, and we have standard errors in the brackets, so you can divide it and you calculate t value. So the formula for t value is slope divided by standard error, and if it is uh, greater than absolute value of 1.96, ignoring the sign, then the particular variable is significant. Okay, so this way you can check. So interpretation says us that tax reforms is increasing tax revenue, political stability is increasing tax revenue, trade in Pakistan is decreasing tax revenue, investment is increasing tax revenue. So this is our long run relation. Normalized long run relation. Normalized mean it is had been calculated and adjusted for the short run and long run effects. So, but there is no short run effect shown here. So what we'll do is we'll go towards the short run estimate. So what we'll do is we'll close it up, we'll estimate it, and we'll now go in vector error correction format, and we'll select it 1. So there's no exogenous variable, and we'll go move like this. Now, but in cointegration, we also know that it's we have went for 1 cointegration, so if 1 will there. If you are going for 2, then you select 2 or 3 or 4 or 5, and we selected model 2 here, so it is there. So no need to do any change in instructions. It be done in advanced models when your model is already developed. So it has given us the formula how to apply restrictions. So when I run it, it will show me the long run model. So here we already know that these are in the y minus y hat is equal to error format, and error equal to 0 means equilibrium. Okay, so now we convert it into since there is equilibrium, so we can write it y minus y hat equal to 0 and y is equal to y hat. So we'll change the signs. So it is TTRE, then 1, the 1 is there, so you can write 1 if you want, if you don't want. So in mathematics, if 1 is multiplied, you can remove it. TTRE is equal to 14.92 plus 1.002 TRDF plus 0.017 POL minus 0.309 TRA PE plus 0.0116 or 0.116 GF CF. So you note that these are same results that we wrote earlier. It means that the normalized coefficients are actually these. So this is the long run equation. So these coefficients are long run effects. Now in short run equation, we check for these things. So I will draw a circle around it. So let me circle. So this is the integration coefficient. Okay, so this is not significant and it should be negative. Okay, so let me select an appropriate color. This should be negative between 0 and -1, and it should be significant. So what does it show us? That it is showing us that there is an equilibrium as per cointegration test, but as per the coefficient of error correction, which I circled, the equilibrium is not that strong. It means if you apply any policy, that equilibrium will break and there will be no coming back to the equilibrium, because the dependent variable will not respond significantly. Okay, so this insignificance means how it is insignificant? Because the t value is not higher than 1.96. So it means that this model in current state is not suitable for policy implications. You cannot use the independent variables to change the dependent variable, because the dependent variable will not respond appropriately. So what you have to do is you need to find more appropriate variables to improve this model. And then next thing to note here is, let's go down and need to see other things. So other these things that are shown here are short run coefficients. So in short run, only none of the variable is significant. All the t values are less than 0.05. So this is the short run effects. Then there's R square, it's very low. So usually in time series, R square is usually high. So R square low means that your independent variables are not appropriate. So let me write it here. So low R square is an indication that the used variables are not appropriate. Because of that, there is no feasible long run relation, as the convergence coefficient or error correction coefficient is not significant. So this way you need to go back and select appropriate variables. And so what let's move up and see what should we do next if it was converging, or if it was significant. What we will do is that what next we'll do is we'll go and check for its diagnostics. So in residual test there is autocorrelation test. Okay, so we'll check lag. So let me select it again. So it's a correlation test. Excluded maximum lag rotor. Okay, let me try it again. So it's a lag test. So I only used one lag. Let me use some more. So it has given us lags up till 3, and it has probability values. So you can note that at lag 2 it is insignificant, and lag 3 it is insignificant. Let me add more so that we can have some robust results. Let's go till 5. So all 4 lags are insignificant. It means up to 4 lags of residuals, there is no auto correlation. Okay, because null hypothesis is. So if you want to make it more reliable, robust, you can go and add more lags. But let me add 8. All of them are insignificant. So it means there was no autocorrelation. But other ways, since the model is not significant, there will be no problem in it too. So let's go forward and let's check more diagnosis. So then there is LM test method. So I will check it at 5. All of them are insignificant, so there is no autocorrelation. This is LM test method. Then we'll go for normality test. There are 4 methods, so you can use any one. So I use the first one, the look to pool method. So you can see the last one, it is significant. So it says that the model residuals are not normal. So how to solve it? The best way is to go back and maybe take natural log and do it again. So it may solve it. But other way you can do is, since your sample size is more than 30, you can use the central limit theorem and assume that the model is asymptotically normal. Then there is in residual, there is a hetero test. You will use no cross terms if your sample is small. If you will use with cross terms if your sample is big, because it requires more sample. So no cross terms, and it is insignificant, means there is no heteroscedasticity. Then we'll go for there are other diagnostic tests like Yes. So there is only then when your model is complete, you can check for the stability. For that, you can use this AR roots graph. These dots should be inside this circle. There's only one dot on the circle. Ideally, no dot should be on the circle or outside. If all of the 1, 2, 3, 4, 5, 6, there are seven dots, and because there are seven lags are there in the model. Some variables have 2 lags. So since all of the dots are inside, it means the model is stable. And once you have a stable model, you can go for creature causality test. So when I run this, it confirms me that my independent variables are not significantly causing my revenue. This is because there was no the the error correction coefficient was not significant and the R square was very low. So this is confirmed here that my proposed variables are not causing the dependent variable in short run too. So long run was the long run was already studied. This is short run, and then it is also checking other variables. So it is showing me that there is only a dependency here for the case of reforms. So these variables are causing reforms, and at the end, these variables are causing investment. So this model is just telling us that in short run, there is no long run because there is no convergence, but in short run, these variables are actually affecting investments and reforms. So this way, you can then what you can do is you can go for impulse response function. So I will show you what to discuss here. So in impulse response function, you will add all the variables. Let me remove all of them and use one so that I can use two so that I can impulses, and you use impulse as tax reforms only and response for tax revenue only. So what it will do, it will show me this graph. So it is saying us that if there is, let me write it here. If there is 1% shock provided to the model via tax reforms, then what will happen that the 1 cent tax reform. Yes. So response of to okay. So at first time period there was 1% shock and there is zero effect. Then in second time period the tax revenue will fall. In third time period it will stay stable, then it will fall. So it means this graph is showing that for 1% shock, the tax revenue will fall continuously till 10 time periods. You can add more if you want to, if you have big sample, but it will not matter if it is insignificant anyways. So let me check it again. In impulse, it was let's see, it was for each time period. Now if you add it, make a cumulative, means add on an aggregate effect. So you take it here, and in aggregate effect it is going down slowly. Okay, so means this is a short run. Means you can say it as what will be happening at that time period only. And if you want to add, see the total effect, you can use this method. So we can change some other variable here rather than tax reform. I will use, let me see if we can use it is, what was the other variable in the model? So let me add, there was one variable. Okay, trade. So when I open it, so this is accumulated, so it is decreasing. So if I uncheck it, let me see, uncheck and okay, so it is decreasing, then it start to increase. Okay, so this is a way we interpret the policy effect in time, how the dependent variable will respond to the shock provided by that variable. So if we don't call it shock, we call it innovation because it's a policy change. Okay, so this way we interpret the impulse response function. Then the last thing that people usually use is the variance decomposition. So in the variance decomposition, so these are the variables. What I will do is I'll make a graph. No, it's better to interpret via table. So let's go for a table. It shows us that uh, for each time period, what is the proportion of each variable to be explained. So at first time period, there was 100% change in the tax revenue. Okay, tax revenue. So in the second time period, this trade explained our trade and political stability explained the major portion. Then it start to decrease. Trade start to decrease. Political stability also decreased, and tax reform started. So it is telling us how in time the variables are playing their role in influencing the dependent variables. So you can see it here that for the case of tax reforms, it is increasing gradually. For the case of investment, it is also increasing gradually. For the polity and trade, it was increased, then it start to decrease gradually. So this way you can see how the effectiveness of independent variables which are used in the model. So this was the tutorial of how to use estimate a VECM model. Eviews. Hopefully you understood a little bit and you will be able to estimate it and generate more knowledge, and then in your discussion you will be able to complete your results.